Hello, everybody. We're going to have a look now at some very tricky level 7 or level 8 questions for you to try. Please pause the video, okay, before each one, so you can have a go before I show you the answer. Then you know you can really do it yourself. Okay, question 1, here it is. Please pause the video and have a go at this. Okay, now I'll go through the answer. So a parallelogram has two adjacent sides with length 4 and 6 centimeters respectively. If the included angle measures 52 degrees, find the area of the parallelogram. So if I was to draw this parallelogram, I suppose it would look something like this, with an angle here of 52 degrees. Okay, so we've got to find the area of that, and I'm hoping you are already thinking about how we can work this into some triangles, because we're doing the area of a triangle formula here. And of course, we can split it into two triangles. And if this is 52, then it's 52 on both sides. And what's really important is we understand that we have in our triangle 26 degrees there and 26 degrees there. Okay, we also know from our work with parallel lines and triangles, we could take those both away from 180 to find this other angle here. So this is going to be 128 degrees. We can also get that using parallel lines and the fact that we have a sort of a Z angle going on if we extend the lines onwards. But hopefully you can see why that angle is 128 degrees. Okay. As well as this, we need one more piece of information, and that is that we're going to have 6 centimeters along the top there as well. So now we have all the information we need to find the area of that green triangle there. That green triangle is going to be a half times sine of 128 times 4 times 6. Half times the A times the B times the sine of the angle between them, sine C. Okay, now as well as that though, we've got two triangles of equal area, because as well as that triangle, we also have this one, which is going to be identical. So to find the total area, perhaps I could just times that whole thing by 2 to take into account that second triangle. Okay, well, 2 times a half can just sort of disappear, I guess. It's going to cancel itself out. So this area is going to be 24 sine 128. And if I work that out on the calculator, it's going to be 18.9 centimeters squared. There's our answer. Okay, on to the second question. This is getting even more complicated now. So for this one, we are given a section of a circle. There is a chord cutting it. Okay, so we have a sector area there. We have to find what that shaded area is. Pause the video now to have a go. Okay, so our technique is going to be the following. First of all, if we imagine this circle and we imagine a pizza slice, okay, with that angle being 135, what we're going to do, we're going to work out the whole thing. Okay, we're going to work out the whole area of the whole pizza slice. And then what we're going to do is next to that, we are going to work out the area of the triangle. Okay, so we're going to work out this area here. And of course, we're going to do one, take away the other. So this shape here is known as a sector. And of course, we have a triangle here. So what we're going to end up doing is we're going to do the sector, subtract the triangle, and that's going to give us what we need. Okay, right, so let's get on with this. So if you think of sectors, a sector is a portion of the entire area of a circle, and we should know the area of a circle is pi times r squared. In this case, we have 7 as our r, as our radius. So it's going to be a proportion of that. And if we think about it all the way around the outside, we have a 360. So if I have an angle of 135, what I've really got is I've got a sort of a fraction of that original area. It's 135 out of 360. So if I work out that calculation, that will give me the area of the sector. So doing that, I can tell you that that is 57.727. All right, and we are in, of course, millimeters squared. Moving on to the triangle now. Well, this is using our triangle formula we already know. So we're going to do a half times a times b. Now, a and b are the same. They're the radius. So we're going to have 7 times 7 times the sine of that middle angle, which is 135. So this is our calculation we need to do for the area of the triangle. If I do that, I'm going to get 17.324 millimeters squared. Okay, so finally, all I've got to do is one take away the other to find myself what I need, and that is going to be 57.7 minus 17.3. This is going to leave me with a final answer rounded to 3 significant figures of 40.4 millimeters squared. Okay, that's how we do it. Let's move on to the final example. Now, this one is way too difficult, really, for a 7-8 question on an exam. I challenge you to try to do this question. So while I read it out, please pause the video and see if you can do it yourself before seeing the answer. So an Australian 50-cent coin has the shape of a regular dodecagon, which is a polygon with 12 sides. 8 of these 50-cent coins will fit exactly on an Australian $10 note as shown. What fraction of the $10 note is not covered? So please pause the video and try to do this yourself first. Okay, I'm going to go through the answer and see if you can follow this. So first of all, let's just think about one of these coins. So it's very hard to draw these coins, so do bear with me. But if we think about what these look like, okay, we're going to have something like this. And again, excuse my terrible picture. And one thing we could say is if we have 12 sides, well, we're going to have 12 identical triangles on each coin. So let's think about those triangles now. Let's think about just sort of taking one of those triangles and thinking about some areas and how we could generate the area of that triangle. Well, we don't know the side length. It's not given to us, so let's call it x. But we do know they're going to be the same, right? We're going to have an x and an x. We could work out the angle, though, between them because we know all the way around our sort of middle of our shape is going to be 360 degrees. So if we take 360 degrees and we divide by 12, we're going to get that, and that, of course, is 30 degrees. So our individual triangle is going to look like that. Now, I don't know what the area is because I don't know x, but I can certainly find an expression for this, okay? So our area of one of these triangles is going to be a half times x times sine of 30. And in fact, if we put sine of 30 into our calculators, and later on, when you get a bit older, you'll know this instantly anyway, sine of 30 is actually a half. So what I've got here is a half times a half, a half times a half times x squared. So that is going to be, let's call it x squared over 4. So that is going to be the area of one of these triangles. But in our coin, we have 12 of them. So we could write down very easily the area of a coin, right? The coin area is going to be 12 lots of x squared over 4. So, of course, that is 3x squared. And going back to our original problem, well, we have 8 of these coins. So all 8 coins, is going to be 8 lots of 3x squared. Well, that, of course, is going to be 24x squared. So this is an expression that we do have, and this is the area of all 8 coins. Okay, now, let's see now if we can go back and look at the note again and work out the area of the note, and then we might be able to find the fraction which is not covered. Now, if we focus in on one of these coins, well, we have thought about these as individual triangles, and we have designated that x is the length of a triangle. Well, if they have got 12 sides, then all the way across one of these triangles, well, that's going to be 2x. So if I've got 2x there, and another 2x across here, and then another 2x on the next one, another 2x on the next one, then overall what I've got here is I've got 8x in length, and I'm sure you've already got the sort of width here, right? This width, of course, is going to be 4x. And I can use this to help me to find the area of the note as a sort of expression involving x. So that the area of the note, let's write over here now, the area of the note, well, that's going to be 8x multiplied by 4x. That's the length times the width. And that is going to be 32x squared. So we have an expression for the area covered by the coins. We have an expression for the area of the note. Now let's go back to the question and read it very carefully to find out, again, what exactly we're looking for. So we're asked to find what fraction of the $10 note is not covered. Okay, not covered. So if we have our note area of 32x squared, and we take away the area that's covered by the coins, which is 24x squared, this is going to leave us with the area that is not covered. Well, that is going to be 8x squared. Okay, let's write that down. Area not covered. So what fraction is not covered is the question. Well, that's going to be our 8x squared, but it's going to be out of the total area, okay? And the total area of the note was 32x squared. So this is going to be the fraction not covered. Well, x squared and x squared can cancel out, so we're left with 8 over 32. And of course, 8 over 32 simplifies down to being a quarter. So we can say that a quarter of the note is not covered. Okay, if you followed that, well done. Okay, those are some very challenging questions on the area of a triangle.